know, is it there? Okay, it is December 2nd. We went to see E.T. yesterday. Played at the Tucson Music Hall. Played by the symphony. So you watch the movie, but they play the music live. It's totally cool. Okay, today you have a little worksheet, writing exponential models. So this is our base sort of parent function of an exponential model. X is in the exponent. And basically, you need to figure out what the A and the B are. And we sort of do the exact same thing when we are solving application problems, which is what we're going to be doing next. The only difference is our exponential model is y equals a times e to the RT, where instead of an x, you use a t, and we're using base e. So because that's just a naturally occurring growth factor, and you have to find the rate and you have to find the a. So it's very similar. So basically, you're plugging in the information you're given. And so we're going to start with this one. Example 1, write an equation of the form y equals a times b to the x for the function graph. So you can just make a little sketch. It's a really terrible graph. This is old. Definitely something I'll redo for next year. I always like to tell you when I use problems from the U of A. These are U of A problems. Y equals a times b to the x. And we have this exponential. Is this exponential growth or exponential decay function? Yeah, it is decay function. You can see that as x is getting large, our y values are getting closer and closer to 0. And it happens pretty quickly. We have this point that they've given us is negative 112. And then I have this point here as well, which is the point 0.06. If we have two ordered pairs, then we can use those ordered pairs to figure out the equation, essentially. So if I have these two ordered pairs, which ordered pair do you think we're going to work with first? 0 and 6, absolutely. I love plugging in zeros. So we're going to use that 0.06, and we're going to plug it in to our generic model that they gave us, y equals a times b to the x. Where do you suppose I'm going to plug in the 0 and the 6? X and y, absolutely. They are always an x and y solution. So I'm going to plug in the 6 for the y and the 0 for the x. Well, what is b to any power 0? 1, yeah. And so we're left with a equals 6. Well, that was pretty easy. So I'm going to take that and plug it right back into my function. So I have y equals 6 times b to the x. Now what do you suppose I need to do? I got to figure out the b. That's what the other point is for. Oh, negative 112. Where are we going to plug in negative 112? For x and y, absolutely. Same thing. They're solutions for x and y. So 12 equals 6 times b to the negative 1. How do you want to solve? Divide the 6. Divide by 6, sure. 12 divided by 6 is 2 equals b to the negative 1. What does b to the negative 1 mean? 1 over b. So I can transform that. 1 over b equals 2. Now what? Multiply by b. Sure, cross multiply if you want to think about it that way. Multiply by b, so 2b equals 1, or b equals 1/2. All right, and so then we just need to plug in our a and b values right back into our function. 6 times 1/2 to the x. This is a great model. Can you multiply the 6 and the 1/2 together to get y equals 3 to the x? No, you cannot. Why not? Got to do the exponent first. Yeah, so we can't multiply these together because we have to deal with that exponent before we can do that. So don't get fancy and think you can simplify. You can't. Just plug it in and be done. Can you check this answer? Yes, of course. It's an equation. It has an x and a y. Plug it in. Use trace to check your ordered pairs. Absolutely check these things against your given information. All right, let's try another one. So this one is passing through 112 and 3, 192. So if you can imagine, I like to graph things. 112, if I were to pretend that was here, 112, well then 3, 192 is super high. So this is a very steep growing function. That space is 12 and that's 300 or 192. Not quite to scale there. Okay. So same idea. We have a model, y equals a times b to the x. So what do you want to do? Plug in a point, absolutely. So we're going to start, I'm just going to plug in the 1 and the 12, mostly because the numbers are small, for x and y. So we have 12 equals a times b to the first. What's different about this problem? It doesn't just clean up real nice, does it? So this one is a true substitution. So just like before we found A, I'm going to go ahead and divide by B just to isolate the A. And then I'm going to take that and substitute it back into my equation. So I have y equals, instead of an A, 12 over B, God bless you, times B to the x. So it is a true substitution. And now, again, I can go ahead and plug in my second order pair for x and y. So I have 192 equals 12 over b times b to the third. Can I clean this up at all? What's b to the third over b? B squared, yeah. So the b cubed divided by b, we can clean that up a little bit. So we have 192 equals 12 times b to the second. All right, and then what do we need to do? Divide by 12, sure, divide by 12. I don't know what 192 divided by 12 is. 192 divided by 12, 16. Hey, it was even. God, math is awesome. All right, and then what do we need to do to get b by itself? Square root both sides. What do you need to remember when you take a square root? Plus or minus. And we need to talk about that just a second. God bless you. So we get plus or minus 4 for the square root of 16. But it's b. In our model, y equals a times b to the x, we had some conditions that I gave you in the very, very beginning of this unit. It can't be negative. B had to be greater than 0, and it also cannot equal 1. You couldn't have b to the or 1 to the first, 1 to the second, 1 to the third. That wouldn't make any sense. It wouldn't be exponential. That's called a constant function. And so because of that rule right at the beginning, I don't have to worry about the negative. So b just equals 4. What do I need to do now that I found b? Go back and plug it back in to figure out the a. So a equals 12 divided by 4, which means a equals 3. And now I can write my model. Y equals A times B to the X. All right. Do you guys have any questions for me so far? Sorry, that wasn't the conclusion of notes. There are a couple of word problems on the back side of your worksheet today. But they should be fine. We're going to do this. Example 2, determine the time. Determine the time. Find the time. That's our directive there. Find t. We are solving for t. Find the time necessary for $2,000 to double. That's interesting. $2,000. What does that mean, $2,000 to double? To turn into 4,000. Sure, if you start with 2,000, we want to know how long will it take to reach 4,000. So the time to double. If it is invested at 4.5% compounded. Oh, funny, I put B and C. That should be A and B, I believe. Quarterly and continuously. So we have to use our interest formulas, and there are 2 of them. And I did these 2 choices, so you'd have to remember both of them. Do you remember what the formula for compound interest is? A equals P times the quantity, 1 plus R over N to the NT. So that's compounded N times per year. What do we use if we're compounded continuously? PERT, yeah, A equals P times E to the RT, PERT. Good. So 2 different models based on what words that they use. So pay attention to the words. If they're compounding continuously, then we use the PERT formula. If we're compounding quarterly or monthly or daily, we use this compound interest formula. So what goes in for P? 2,000. Yeah, that's that stuff, the money we're starting with. And we're trying to figure out the time necessary for that 2,000 to grow and turn into what? 4,000. We want to know how long it takes to turn to equal $4,000. And then what should we use for R? 0.45? 0.045, 2 decimal places, 0.045. And this is compounded quarterly. If we're compounded quarterly, N equals what? 4. Good. So over 4, and then this is going to be, oh, sorry, I put 4, 9. All right. 4, and then 4 times T. And we're trying to figure out what T is. So we're going to solve for T. You actually had some problems like this in your homework on Friday. What do you want to do first? Divide by 2,000. Absolutely. What a great start. And you'll notice when we divide by 2,000, 4 divided by 2,000 is 2, thus the doubling factor. All right, that's what that means. Okay. And we're left with 1 plus 0.045 over 4 to the 4t. Again, 1 plus this is just a number. But we do need to solve for t. So what do I need to do in order to make that power drop down? Natural log. Yes, we're going to take a natural log of both sides. So I have the natural log of 2 equals 4 times t times the natural log of all the garbage. And then how do you get t by itself? Divide by all that stuff. Sure, divide by the 4, divide by the natural log of 1 plus 0.045 over 4. So 4, and the natural log of 1 plus 0.045 over 4. And again, this is the hard part, is really just plugging it into your calculator. But we did do a couple just like this in your homework. So I'm going to plug that into my calculator. The natural log of 2 divided by the entire 4 natural log of 1 plus 0.045 over 4. And just make sure you're plugging that in correctly. You can do it all in one long line if you're careful about putting parentheses on there. All right, I get 15, probably 0.49 years, roughly. To double. About 15.5 years to double. It seems like a long time to take $2,000 and turn it into $4,000. Okay, so then we also want to know if it's compounded continuously, how long do you think it'll take to double? What do you think? Is it going to take more time or less time? Less time. So same thing. We're starting with $2,000. My initial amount was $2,000. And our rate is 0.045. We're still solving for t. We want to find the time it takes to equal $4,000. So we're finding the time to equal $4,000. Same setup. What should we do first? Divide by 2,000. Absolutely. Isolate your base. So 4,000, again, divided by 2,000 is 2. All right, what do we do next? Natural log both sides, which is going to allow my power to drop down. And I like this model so much better. 0.045 times t times the natural log of e. What happens to the natural log of e? 1. Very good. And then how do you get t by itself? Divide by 0.045. So it's so much nicer, isn't it? So t is approximately, let's see, so the natural log of 2, divided by 0.045. 15.40 years to double. Not much less time, maybe. Okay. Not much of a difference. All right, do you guys have any questions for me? All right, super.